Day 595 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2092, find all people with secret. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer n indicating there are n people numbered from 0 to n minus 1. You are also given a 0 index 2D integer array meetings where meetings of I is equal to xi, yi, and time I. Indicates that person xi and person yi have a meeting at time I. A person may attend multiple meetings at the same time. Finally, you are given an integer first person. Person 0 has a secret and initially shares the secret with the person first person at time 0. This secret is then shared every time a meeting takes place with the person that has the secret. More formally, for every meeting, if a person xi has the secret at time I, then they will share the secret with person yi and vice versa. The secrets are shared instantaneously. That is, a person may receive the secret and share it with people in other meetings with the same time frame. Return a list of all of the people that have the secret after all the meetings have taken place. You may return the answer in any order. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input n equals 6, meetings equals a 2D array of integers. That first array is 1, 2, 5, then the second array is 2, 3, 8, and the third array is 1, 5, 10, and first person equals 1. The output is an array of integers 0, 1, 2, 3, and 5. So let's go ahead and take a look at this explanation so we can see how they got this output from this input, right? So the explanation says at time 0, person 0 shares the secret with person 1. So boom, first person to get the secret is 1, right? So that's why person 0 shares the secret with person 1 because it says first person is equal to 1. So that means person 1 is the first person to get the secret. Boom. Then it says at time 5, person 1 shares the secret with person 2. So we know person 1 has the secret, right? And then we come up here and we see person 1 and person 2 have a meeting at 5, right? Because it says right here, xi, yi time. So person xi and person yi have a meeting at time I. So what that means is this is person xi, this is person yi, and this is time I, right? So person 1 and 2, once again, have a meeting at 5. So that is when person 1 is able to share the secret with person 2, right? So now person 2, person 1, now person 0, person 1, and person 2 all know the secret. Boom. Now 2 knows the secret and 2 has a meeting with 3 at 8, right? So it says at 8, person 2 shares the secret with person 3. So once again, we're right here, person 2 and 3 have a meeting at 8, and that's when person 2 is able to share the meeting with person 3. Boom. So now person 3 has the secret. So then it says at time 10, person 1 shares the secret with person 5. So now person 1 already has the secret. Person 1 and 5, they have a meeting at 10. So at 10 o'clock, person 1 will be able to share the secret with person 5. So in the end, the people 0, 1, 2, 3, and 5 know the secret after all of the meetings. So that's why we return the output 0, 1, 2, 3, and 5. Now, just in case that didn't make sense, let's take a look at example 2. So excuse me, y'all. In example 2, we have our input n equals 4, meetings equals a 2D array of integers, the first array being 3, 1, 3, second array is 1, 2, 2, and the last array is 0, 3, 3. This time, first person is 3. The output is 0, 1, 3. Boom. Explanation says at time 0, person 0 shares the secret with person 3. So since first person is 3 this time, that means person 3 is going to be the first person to get the secret. Then it says at time 2, neither person 1 nor 2 know the secret. So coming back to we're looking at this array right here, because if we're looking at meeting times, the earliest meeting is at 2, right? This 1 and 2 have a meeting, person 1 and 2 have a meeting at 2, then everybody else, person 3 and 1, they have a meeting at 3, and person 0 and 3 also has a meeting at 3. So that means 2 is the earliest meeting. But since the first person to get the secret was 3, and the meeting at 2 is between 1 and 2, that means 1 and 2 do not know the secret at the time. So once again, that's why it says at time 2, neither person 1 or 2 know the secret. Then at time 3, person 3 shares the secret with person 0 and person 1. So as you can see, at 3 o'clock, person 3 has a meeting with person 1, and person 3 also has a meeting with person 0. So person 3 is able to share the secret with person 1 and 0. That's what it's saying right here, right? At time 3, person shares the secret with person 0 and 1. Because remember up here, it says the secrets are shared instantaneously, and that is a person may receive the secret and share it with people in other meetings within the same time frame. So, and it says right here, person may attend multiple meetings at the same time. So that's what's going on right here. Person 3 has 2 meetings at the same time, but during those meetings, he's able to share the secret with 2 people. He can share the secret with 1 and 0. So now 0, 1, and 3 know the secret. So there it says right here, it says, thus people 0, 1, and 3 know the secret after all the meetings. And that's how we got the array, the output array 0, 1, and 3. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, we have input equals 5, meetings equals a 2D array of integers. That first array is 3, 4, and 2. Then the next one is 1, 2, and 1. And the last one is 2, 3, 1. And first person equals 1. The output is 0, 1, 2, 3, and 4. So let's look at the explanation. It says at time 0, person 0 shares the secret with person 1, right? It says first person equals 1. That means 1 is the first person to get the secret. Boom. It says at time 1, person 1 shares the secret with person 2, and person 2 shares the secret with person 3. So this is another one of those cases where we have 2 meetings at 1. We have a meeting at 1 right here between person 1 and 2, and we also have a meeting right here between person 2 and 3. So at 1 o'clock, person 1 is going to share the secret with person 2 right here, boom, and then person 2 is going to share the secret with person 3 right here. Boom. Then it says, note that person 2 can share the secret at the same time as receiving it. Then it says at time 2, person 3 shares the secret with person 4. So we also have this meeting right here where which is at 2. Remember, person 3 just had a meeting at 1. So person 3 already knows the secret when 2 o'clock comes around. And when 2 o'clock comes around, person 3 is able to share that secret with person 4, right? That's what this is saying right here. And thus at the end, people 0, 1, 2, 3, and 4 know the secret after all meetings. So that's how we got the output 0, 1, 2, 3, and 4. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get into it. Now, first thing we're going to do is we're going to create an adjacency list where meetings map of I contains all meeting involving person I as so we're going to say declare a variable. Sorry, I will come right here. Declare a variable, call it meeting map. We'll set that equal to a 2D array of tuples. So we're going to say square bracket, open up the parentheses. We're going to say P colon int, comma T colon int. Boom. Then we're just going to come outside of that, open up the parentheses, and we'll initialize it with a repeating colon, a blank array. Come outside of that, and we'll say comma count colon n. Boom. Then we need to build a graph from the meetings input. So we'll say for m in meetings. My bad, let me get some space right there. Boom. For m in meetings, we're going to open up the brackets and we'll say let open up the parentheses x, comma y, comma t. Come outside of those parentheses, we're going to set that equal to open up the parentheses, m square bracket 0, comma, m square bracket 1, comma, m square bracket 2. Boom. Then we need to add the meetings to both participants since the graph is undirected. So we'll come underneath this and we will say meeting map square bracket x, come outside of that, we'll say dot append, open up the parentheses, pass in p colon y comma t colon t, come underneath that, we'll say meeting map square bracket y, come outside of that, we're going to say dot append, open up the parentheses, p colon x comma t colon t. Boom. And sorry y'all, this should be a tuple as well, so we need to wrap this in parentheses as well, just like this. Boom. Boom. Okay. Now we need to we're going to need to create a struct that's going to represent a potential secret sharing event. So we could just come down here. We're not done with this main function, but we could come down here to create the struct. We're going to say struct share event, open up the parentheses, or excuse me, no parentheses. We're going to say colon. It's going to be comparable, open up the brackets, we're going to say let p colon, that's going to be an integer, comma t colon, that's going to be an integer as well. Then we're going to come underneath this, and events are ordered by time, so earlier shares are processed first. So we're going to say static func less than, open up the parentheses, LHS colon share event comma RHS colon share event. Then we're going to come outside of that. We're going to say it's going to return a Boolean, and we're going to say LHS comma T is less than RHS. I mean, not comma T, period T. Then we're going to say RHS period T. Boom. Now we come back up here, and we'll come underneath this for loop right here, and we need a min heap priority queue ordered by time, starts with person 0 and first person both knowing the secret at time 0. So we're going to declare a variable called PQ, set that equal to heap less than share event greater than, open up the parentheses, open up the square brackets, and we are going to come right here, and we're going to say share event, open up the parentheses, p colon 0, comma t colon 0. Boom. Then he's going to come underneath that. He's going to say, and we're going to say share event, open up the parentheses, p colon first person, comma t colon 0. Boom. Now we're going to track whether each person has already learned the secret by coming underneath this variable, declaring another variable. We're going to say told secrets, and set that equal to an array of booleans. Come outside of that, open up the parentheses. We're going to say repeating colon false, comma count colon n. Boom. Then we're going to process events in increasing order of time. So we'll come underneath this, and we'll say while let s equals pq dot pop min, put the parentheses, open up the brackets, and if this person already knows the secret, we can skip. So we'll say if told secrets, if told secrets square bracket s dot p, come outside of that, open up the brackets, we could just say continue, and that's what's going to skip it. Boom. Then we need to mark this person as having learned the secret, so we're going to say told secrets, square bracket, s dot p, come outside of that. We're going to set that equal to true. Boom. Now we're going to explore all meetings for this person by saying for, open up the parentheses, p2, comma, t, come outside of those parentheses, in meeting map, square bracket, s dot p, and we're only going to consider people who don't yet know the secret in meetings that occur at or after the time this person learned it. So we're going to come underneath this, and we're just going to say where, exclamation point, told secrets, square bracket, p2, come outside of that, and two and signs, t is less than or equal to s dot t. We're going to open up the brackets. Boom. Then we are going to say, we're going to schedule an event where the secret is shared at time t. So we can say pq dot insert, open up the parentheses, share event, open up the parentheses, insert, open up the parentheses, and we are going to say p colon p2 comma t colon t. Boom. And then we're going to return all people who ended up knowing the secret by coming right here underneath this while loop, and we're going to say return, open up the parentheses, 0 dot dot less than n, come outside of that, dot filter, open up the brackets, told secrets, square bracket, $0. Boom, y'all. So let's go ahead and give this a run. Make sure it runs properly before we submit it. Okay, we got an error. Let's see. This should be, oh, need a comma right here. That's what that is. So let's run it again. See if that did a trick. Okay, now we got an error up top. No exact matches and call. Oh, this should be repeating with a T. Now let's run that again. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 77 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom, or this is the middle, I should say. And then this is the bottom. Boom, y'all. So I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.